And gravity's been around for how long?
Ever.
A long time. So people have had a long time to try to figure out what's going on with gravity. What's the deal? And a while ago, there was someone named Aristotle.
Hey, where are you going?
He was back in Greece. And he got two objects, and he said, if I drop them, which one's going to hit the ground first? Now, he didn't have a basketball and a racquetball. He had a rock and a feather. And we could probably go pluck one from the chicken and go find a rock somewhere else. But we're going to do this right now because somebody else named Galileo decided, well, I want to make these two objects a little bit more like each other. So I'm going to get two things, one just being bigger, one being smaller than the other. And he said, hey, student of mine, you see that really, really tall thing over there, the Leaning Tower of...
Pizza.
Pizza, yes.
Pizza.
He said, student, I want you to carry these two cannonballs up to the top and drop them, and then pick them up again and do it again. And we're going to figure out which one hits the ground first. So we're repeating that. Who thinks that this ball is going to hit the ground first?
What does it weigh?
Oh, it's heavier.
It's heavier than that one?
Yeah.
A couple of pounds. WNBA standard.
Well, we'll have to test it. So make your predictions, everyone.
Blue.
Here we go.
Blue.
All right, and they're off to the races.
Same.
Good rebound.
They seem to be same.
It was pretty close, huh? Should we try it again? Yeah. Yeah. All right.
Same.
Oh,
Basketball, I think.
it was the basketball.
Pretty same.
Now, you know what I'm starting to think is maybe I can't drop them at the perfect exact same time. So maybe I should go swap out my brain for an electronic one and then everything will work. Or not. Maybe we'll just have to keep repeating it.
Maybe try them from
Or how about you put it
upside
on
down first, and then...
ladder you have, and then like roll it up.
Well, that's a great idea. Now, can you do this at home? Can you make this experiment better than I'm doing it?
Yeah.
Yeah. So, well, I'll move on to one other thing. Now, when I drop these, how high do they come back up? Not all the way, right?
Like halfway.
Like halfway. And sometimes it depends on the thing that you drop, right? So, I'm going to show you a way that if you drop them, one of them actually goes higher than the other. And I promise this isn't magic, even though we're hanging out at this beautiful farm that almost seems like a fantasy. All right, you ready? And I might need some of the youngsters to chase this down. Here we go. Whoa! So the blue ball went way into the air, but who saw what happened to the basketball? It didn't go very high, right?
Yeah.
Now, in science, we always have to we have to change our experiment. We have to make something a little bit different. So, I'm going to add another ball in here, and then I'm going to drop them. Make your prediction. What do you think is going to happen to that blue ball?
That's super high.
All right, here we go. Whoa! Yeah.
That looks like fun.
Hey, why don't you give that?
Oh, yeah. All right. They've all came back.
Thank you. I don't get that.
So the blue one went way up into the air because we added this ball. Now, I hope that we're doing this segment of the show because I'm going into it anyways. Does anything strike you as funny about this ball? Like, is there something on this ball that you can tell me?
It's plastic.
It's plastic? It's rubber, sort of like plastic. Well, but there's something that's on all of the ones that we're holding.
Air?
Princesses! Yes! And this is the time in the show where we remind everybody that for a long time science was done by men and old men with no hair. Now, that's because we were a little backwards. And now, we just want to remind everybody that boys and girls especially, need to do science because they're just as good and sometimes better than boys.
Frequently better. What would you say, James? Okay, ladies and gentlemen, back to the main stage. That's right. Ladies and gentlemen, girls, boys, and everybody.
Not backwards.
Just trying to figure out this whole gravity thing.
Well, and as soon as you figure out gravity, then you can start on anti-gravity. If gravity makes things fall, anti-gravity is anything that holds things up.
Oh wow, that's pretty impressive.
Like the mysterious force that seals use to balance a ball on their nose.
Now, does anyone here think they can balance a ball on their nose? Will you come up?
Yeah, give it a try,
I'd like you
bro.
to try briefly.
I want to.
Will you try with this one? All right. Is that challenging?
Practice.
So hold on, we're gonna keep you up here for just a minute.
Practice.
Try with the bigger one. See if it's easier with the bigger one. It might be a little bit easier. And if it's easier with that one, oh, maybe we should go the other way. Let's try a small one.
Okay, there you go.
Try the racquetball. So which do you think we got it?
That one.
Ah, that one was the easiest?
That's so odd.
And that one was the hardest? But this one was somewhere in the middle, right?
Yeah.
Now, so if it fell sort of that way, which way would you have to put your nose to make it not fall down?
This way.
That way, sort of underneath it again, right?
Yeah.
Now, what would happen if I told you I had a magical machine that when it started to fall, say, to my left and to their right, that it would push it back? Do you think that would make this easier? So it would always push it back from whichever way it went?
Yeah.
Yeah? Would you like to see my magic machine? Here it is, right here. Alright, now, I need everyone to be really, really quiet so you can hear the leaf blower. Alright, will you hold this?
Leaf blower? I thought it was a magical machine.
It is. It's a magical leaf blower. I'm going to ask you to hold the ball above here and then come down to about here, and when it feels like it's weightless, let it go. Alright?
Check, maybe a little bit less guitar.
Try it.
Check. A little more vocal, 1 and 2.
Guys, will you come up here? Come a little closer, because now they're doing the sound check. Nobody can hear our leaf blower.
Will you hold this one for a minute? Are you ready? You're gonna do the same thing, okay?
Oh, you push it a little bit.
Alright, will you grab it? Thank you.
Wow.
Okay, and now.
Good job.
I'm going to select another volunteer.
Yes, sir.
And because whenever you're doing experiments,
we want to vary different parameters. So, for example, both these balls were smooth.
Very good.
And this one is much smaller. It might get shot up way up into the trees.
I forgot your name.
Bo.
Bo.
So notice,
okay.
what was weird about the tennis ball?
We're here to tell Bo, don't be discouraged.
Well, it's not smooth?
Yeah.
It's a little different. Absolutely. We're going to let Bo try it one more time. But now our hypothesis is that maybe what's on the surface makes a little difference. And you might notice that one of the differences. How did I come? I chose Bo. Well, Bo has plenty of fuzz on the outside, just like the tennis ball that I gave him. I have a little fuzz on the outside, just like the racquetball and the other ones we've been trying. And I don't know if you've ever wondered how come airplanes don't have green fuzz on the outside. But you can probably. Well, now you have a hypothesis.
He has a bigger brain. Can you notice the difference in the brain size?
That device works with fast-moving air. Sometimes we want to study slow-moving air, so we built this device.
That's right, because
a fancy device.
In fact, we sometimes talk about safety. You know, you don't want to point this at somebody's.
Maybe I need to go downwind. And what does it make?
Smoke signals.
Look at those, they're like perfect Cheerios. And I'm gonna go over here so you guys can have it coming straight at you. You can see them coming at you. Are you ready? Do you feel that pulse of air?
What's in it? What is it? What's the smoke? What's smoking in? What's oh, that's it. That's connected.
Okay, a little more.
Now this isn't like cigarette smoke. It's actually theater fog, so it's not toxic or anything. But it does smell kind of funny. You ready? And notice what happens when you get in the way. They sort of pop, right? On the other hand, if we let it go, if we don't get in the way and I shoot it up high, look how long it lasts. It just keeps going and going and going. What else do you know that is sort of round in shape? And if you touch it, it'll pop, but if you let it go, it'll last for a long time.
Bubble.
Bubbles, right? So it might be that there's something special about these. They're sort of like bubbles. Now we've got one more demonstration for you guys, and we're going to talk a little bit about temperature. And we've got this stuff called liquid nitrogen. Now you guys might know nitrogen is mostly what the air is made out of. But to get it to form a liquid, you have to get it down to like minus 250 degrees C. Alright, so that is really, really, really cold. And it's so cold that it can freeze things instantly. Now let's watch. Chris is going to do a few cool things with it. Now, do you need me to hold anything?
I got it all.
All right.
So that last demonstration, you guys probably have a trash can at home, right? And again, when your parents aren't home, you can cut a hole in the bottom and make a...
And you can even see how cold it is. Frost is already forming on the outside.
This stuff you can't get at home. We get this at, there's a place that makes liquid nitrogen just south of downtown.
Like, okay. It won't hurt you, but...
So yeah, you can see it looks like water pouring out.
But suddenly it forms a gas and it's evaporating.
It freezes this thing instantly.
And you can see, those are all frozen. Yep.
Oh.
So now we're going to freeze some other things really quickly.
What do you think would happen if I freeze a banana?
It'll freeze.
Yeah. And this will let you know what happens if you stuck your finger in here. Because your banana is kind of soft like your finger, right? This is a real banana? Okay, let's stick it in there and let it freeze. And you can see it's boiling. If you look in there, don't stick your hand in there.
It's so cold, it's boiling.
Yeah, this stuff boils at, what did he say? Minus
250 some degrees C.
Yeah, maybe. Oh yeah.
Or they actually call it boiling.
It's about
I played with
300 degrees colder than ice. Now, this will take a while to freeze, but we can take a flower. James can take some flowers. We're gonna freeze some flowers.
As long as you get it off fast, it's not going to be a problem. But check this out. Now,
perfect. Now, let's see what happens when we have frozen flowers. James is gonna high five me
with the flower. And it shatters.
They shatter like glass. Do you hear that?
I'm gonna take a picture.
Let's do another flower.
But all these flowers are making me hungry.
Well, let's do a flower and then we can eat something.
Oh, okay. I always have to wait for my snack time.
Let's freeze these.
Wow,
and they freeze super fast.
Why don't you put the theater gas?
Who wants to crunch some flowers with their hand? Who's brave enough? Whoa! Just crunch them. Yeah. So the flowers don't hold onto the cold for very long, so it's okay to touch those with your hand.
Can we check on the banana now?
Let's check on the banana. The banana, you don't want to touch it because it's gonna pull all the heat out of your hand, or it's gonna be really, really cold. But now, what can we do? Let's see if we can hammer it with it. Or we can, do you hear that?
Yeah, you don't really want your finger to do
banana
that.
sound like that?
Normal banana does not sound.
Try to crunch it. Crunch it. What happens if you put the theater
Here,
gas
I'm gonna go.
Did I hear somebody say you don't really want to do that with
Do
your
you
finger?
feel how hard that is?
Ooh.
Is it cold too?
What's gonna happen with these? It's gonna pop. Nope. It's gonna squeeze and no air.
It's really, really cold. And it's really solid. So we'll put that back in there.
So remember how we said the gas around us is mostly made of nitrogen, and that's liquid nitrogen. So we've got a gas in here.
This young man has a hypothesis, so maybe we can let him.
Once you put it in, air will.
Okay, so
let's see what happens when we stick a balloon in here.
Yep.
How are we doing on time? What time is it?
122.
Okay, good.
Excellent time.
Do you see it's
So all the air is turning into a liquid, and a liquid takes so much less space than an air that it looks like all the air is coming out of it. But the air is still in there. It's just really, really tiny now.
The end is still tied in the knot.
Now let's watch what happens when we take it back.
So this is like when you guys are on the playground, you're running around, and how much space do you take up on the playground? A lot of space, right? But when you get tired and you come back in the classroom, you can fit into a smaller space. And look at the balloon.
So watch what happens as that heats back up. So what happens to a gas when you heat it up?
I knew it!
It takes up more space, right?
If you blow on it, it helps. This is my favorite way to blow up a balloon.
I'm blowing up a balloon without even touching it.
You put the theater gas in there.
So now I'm getting a little hungry. I'm gonna make a snack. So I'm gonna eat some graham crackers.
No! Is that safe?
Yeah, let's try this.
Well, as long as he actually drips the liquid nitrogen off,
Yeah.
so that he's not actually eating liquid nitrogen,
And then-
it's okay to eat a cold graham cracker.
That's the perfect solution. These have been in our box for years. They're totally stale. But after you dip it in liquid nitrogen, it's perfectly crunchy.
Now we have one last quick demo, but we need 2 volunteers that are about the same height.
Wait,
So,
one more demonstration to do. I'm kind of thirsty.
Oh yeah.
Want a cup?
And in fact,
Man, kind of freezing.
wait. That cup is it got all cracked up because
Because we used it.
actually it does seem to be working.
Yeah, just gonna pour some in this cup.
Okay.
Oh, the banana's making a run for it.
Okay.
Oh, this cup is cracking. And I'm gonna pour some liquid nitrogen into this beverage of mine.
Okay.
And then that's, yeah.
I smell wine.
And so I'm cooling down my drink here. And you see that I'm kind of thirsty, but it's not mixing. So I'm gonna have to mix it a little bit. All right, so. Now you guys are all clean. It's soapy water. I'm sorry about that.
What happens if you put the like cleaner gas in the nitrogen?
So it'll. Good question.
Yeah.
We'll have to try that some other time.
We have to move on because the music is going to start, but we're going to continue to do fun stuff over on the stage.
Yeah, so we're gonna be doing some stuff. It'll take us a little while to get set up, but we'll be doing some other experiments over there for you guys to try.
We're going to
Okay?
do more liquid nitrogen stuff, so yeah, stick around. We'll be over there.
But really,